Now let us see elasticity. Elasticity is very important in engineering practice. I've told you earlier that every system has a habit of opposing changes. That is a basic inherent property of every system. If you take a solid body, in engineering practice, we are interested in three things. Before that, you can classify force into two. One is accelerating force, that is associated with Newton's law. That is force which changes the velocity or that produces the acceleration, that is connected with moving bodies. That is called, such a force is called, or a force that supplies acceleration or that changes velocity of motion is called accelerating force. Another type of force is forces which change the shape, size, etc. of material bodies. Such forces are called deforming forces. Now we are interested in deforming forces. A solid body, we are interested in three types of strengths. A solid body is strong enough to oppose any act of changing its length, changing its volume, and changing its shape. The capacity of a body to resist any act of changing these things, that is length, volume, and shape, is called elasticity. A body of high elasticity means it is very difficult to change its length or to change its volume or to change its shape. On the other hand, a liquid, you can change its shape or length easily. If you transfer water contained in a spherical vessel to a cylindrical vessel, its shape changes automatically without any effort. So it doesn't have elasticity of shape. You can change its length. You can transfer water from a short cylindrical vessel to a tall cylindrical vessel. There is no resistance. That means liquid has no capacity to oppose the act of changing its length or changing its shape. But it's very difficult to compress a liquid. That means liquids have elasticity of volume. Gases also have elasticity of volume. But solids have three elasticities, that is elasticity of length, that is capacity to resist any act of changing length. 2. Elasticity of volume, that is capacity of a solid body to resist any attempt to change its volume. 3. Elasticity of shape, that is capacity of a solid body to oppose any act of changing its shape. The solids have in general three strengths or three elasticities. Elasticity or strength connected with the change of length is called Young's elasticity or elasticity of length or Young's modulus of elasticity. strength connected with volume change is called elasticity of volume or bulk modulus of elasticity. 3. Strength to oppose change in shape is called elasticity of shape or rigidity modulus. Now let us see the first one. This is a thin wire or of cylindrical shape. Its area of cross section is A. It is fixed at the upper end. We pull it downwards to increase its length. Such a force is called a tensile force. Now the body will resist. That means a restoring force will develop inside the wire. That will try to cancel the increase in length, or it will oppose the applied tensile force. This restoring force per unit area of cross section is called linear stress. Linear stress. Linear stress is the restoring force developed in a body when its length is increased. Another one. Suppose you try to decrease its volume by pushing it up. Then restoring force developed will try to cancel that force, or a restoring force will develop opposite to this applied force. There also, this is called compressive force. There is also a stress developed, and that stress is equal to this restoring force per unit area. That is called compressive stress. Both these stresses are commonly known as linear stress. Linear stress means restoring force developed per unit area when we try to change length of a body. But at equilibrium, this restoring force will become equal in magnitude to this applied force. So you can define stress as either restoring force by area or applied force by area when the system is at equilibrium. Then this is called tensile stress, this is compressive stress. Both these stresses are combinedly known as linear stress. Now there is a factor called strain. Strain means change divided by original something. In this case, length is increased. So let delta L be the increase in length. Then the ratio delta L by original length is called linear strain. Here it is specially known as tensile strain. Here decrease in length occurs. This decrease in length delta L by original length, that is called compressional strain. Both these combinedly known as linear strain. So linear strain means change in length divided by original length. It has no unit, but stress has the unit of Newton per meter square, that of pressure, or called Pascal. Now there is a law connected with this stress and strain. If you stretch a wire without any restriction, it will break and it won't come back to the original length. So there is a limit. That limit is called elastic limit. Within the elastic limit, there is a law called Hooke's law, which states that within a limiting stress or strain, the ratio stress by strain is a constant for a material. that constant is represented by y and is called the Young's modulus of elasticity. Young's modulus of elasticity. So what is Young's modulus? Young's modulus, y equals linear stress by linear strain. That is F by A, stretching force by area, or compressive force by area divided by change in length by original length, or y equals F into L by A into delta L. This formula must be remembered for further analysis and discussions. We will see the rest in the next postings. Thank you.